A 60 kilogram person jumps onto the floor from a height of 3 meters. If he lands swiftly with his knee joints compressing by 0.5 centimeters, calculate the force on the knee joint. This person's energy is brought to zero in this situation by the work done on him by the floor as he stops. This work done by the floor reduces this kinetic energy to zero. First we need to write the work done, and then later we will use energy method and work energy theorem. Let's start with the work equal F dot D. The force that's going to stop is upward and displacement is still downward, and the angle between these two vectors is 180 degrees. Therefore I can rewrite this as multiplication F times D cosine 180. Cosine term is minus 1. With that we have minus FD. Now let's think that this person is here first. This is the floor, and the height is, let's call 8. And later on this person is landing for the first time on the floor, and later on the joints are compressed. This is the joints are compressed form. Let's call this state 1, state 2, and state 3. Now we can write the energy conservation. Mechanical energy for state 1 equal mechanical energy for state 2. The only energy at state 1 we have is potential energy, because no speed, therefore no kinetic energy. So we write potential energy mg, and the height that we defined as 8, mg8. When the person lands on the floor for the first time, state 2, based on this reference level, no potential energy, we have kinetic energy 1/2 mv2 squared. We can drop these mass terms and rearrange to solve for V2. V2 becomes 2 times V8 root 2 G8. Between state 2 and 3, we write work energy theorem to find the force. Work equal changing kinetic energy. Work we found above is minus Fd. Kinetic energy 1/2 mass. It was between 2 and 3, so that means final is 3v3 squared. Technically this term is 0 because the person is stopping eventually, minus v2 squared. And I need to simplify first, minus Fd minus, because of this minus, 1/2 mv2 squared. Now we drop these minus terms from both sides. Now we can rewrite as F equal m/2d square of v2. m/2d 2g8. We can drop these 2. After simplification, let's start here. F equal mgh over D. M is 60 kilogram. G is 9.8 meter per second square. And the height is 3 meters. This height over distance is given as 0.5 centimeters. So it is in centimeters. We need to convert that into meters. 0.005 meters. Now we need a calculator. 60 times 9.8 times 3 over 0.005. 352,800. The unit is kilogram. Meter times meter. Meter squared. There's another meter here. We can actually cancel this. That means the only unit left is kilogram meter per second square. This is Newton. We can also rewrite this in scientific notation. 3.53 times 10 to the 1, 2, 3, 4, 5 steps, 5 Newton.